My friends, today I want to talk to you about how you can use tree diagrams to represent compound events. So, what's a compound event? A compound event, well, as you remember, an event is something that occurs when we're talking about probabilities, like what the outcome was of a probability experiment. A compound event is what the likelihood of multiple probability outcomes are. So, for example, here I have a coin. We whirled a bunch of Washingtons the other day, and you got to see what the theoretical versus the experimental probability of a heads coming up is. But that's just one outcome. Does a heads come up when I flip one coin one time? This is going to be more like, what's the likelihood of me getting heads every time if I flip the coin, let's say twice? One, I got a tails, so now it's not going to happen, right? And then two, I got tails again. So we can use a tree diagram to represent all of the possible outcomes, and then from that, give ourselves some probabilities to work with. Let's take a look. So if I were to flip a coin, I've got my coin here. Here's Washington. Boy, bad. I mean, always room for improvement in the arts. I put the A in STEAM, don't I? Okay, so here's Washington. Hi, friends. And I flip him. Boom, boom. And I get a heads or a tails. So with one flip, you can see if the likelihood of me getting a heads would be 1 to 1 or 50%. So now the next thing to do is to represent what would happen if I flipped the coin again, no matter what my outcome was. So I'm going to say, if I flipped my coin again, I could get a heads or a tails. And then over here, if I had flipped tails, the same thing is still true. I could flip it again and get a heads or a tails. And now this tree diagram, does it remind you of the prime factorization tree diagrams that we used earlier this year? This tree diagram is representing every possible outcome for 2 flips in a row of a coin. And so if I wanted to know what is the probability of flipping a heads twice in a row, then I would have to find every different option here that fits that criteria. And you'll see the only one is we have to go this route to here, and then we also have to go this route to here. So this is the one outcome that fulfills that requirement, and that is 1 out of 4. And so there's our fraction, 1 out of 4. It is a 25% chance if you are to flip it twice to get heads twice. So then, why don't we just take it one flip further? If I were to flip it again, let's take this out of here. If I were to flip my coin again, I would have to represent it from every flip here. So I'd go heads, tails, heads, tails, heads, tails, heads, tails. And now, if I wanted to know what the likelihood of flipping heads every time 3 times in a row, I'd have to do the same thing as I did before. I'd find the route that ends up in heads with every flip. So that's the heads for this flip. Next flip, this is the only one that can go from heads to heads. So that's it. And then same thing here, this is the only one that can go from heads to heads to heads. And so this is my only outcome that fulfills that next requirement of 3 flips in a row, 1, 2, 3, where each one was heads. And so now I just count it up versus all my other outcomes. There's 1 out of 1, 2, 3, 4, 5, 6, 7, 8. 1 out of 8. And so that is how you can use a tree diagram to represent a compound event. Thanks, guys. Have a great day.